Welcome to the AI Models module. This module is designed to help you view and manage all your AI models in one centralized location. No matter the type of model, you'll have full visibility and control right from this page. All the models you've created will be listed right here on this page. For each model, you can easily view important details such as the name, accuracy achieved, model type, the dataset used, the departments with access to the model, its current status, and quick access to various actions related to the model. Creating a new AI model is simple and straightforward. To get started, just click on the Create New Model button located at the top right of the page. On this screen, I can provide the basic details required to create the model. I'll name my model Customer Selection for Cold Calling, as this AI model will assist the marketing team at a bank in identifying customers most likely to respond positively to a cold calling campaign. I'll select the model type as machine learning, as this aligns with the requirements for this use case. For the method to build this model, I'll choose Build Your Own Model, since I want to build and train my own custom model. Alternatively, selecting Use Ready Built Model would allow me to install one of the pre-built AI models available in the AI Model Store. I can now select the machine learning algorithm I want to use for my model. Cranium offers a wide range of popular ML algorithms to choose from. For this use case, I'll choose Random Forest Classifier, as it is well suited for solving classification problems like this one. I'll click on Next to proceed to the next step. In this step, I need to select a dataset to link to my model. I can either choose from one of my existing datasets or create a new one. Since I've already imported the data into Cranium, I'll select an existing dataset for this model. I'll now click on Next to proceed to the next step. I don't want to enable auto-training for this model, so I'll leave that option disabled. Next, I can select which departments will have access to this model. For this use case, I'll choose the marketing department. All right, we're all set to create our new AI model. Let's go ahead and click on Create to finalize the process. Cranium will automatically redirect you to the new AI model screen as soon as it is created. This is the detailed page for the model, where you can track and manage everything related to this particular model. The AI Model tab presents details about this model. I can track everything from the accuracy of the model, to model architecture, to metrics, recent activity, and the timeline of accuracy on this page. I can also change the algorithm of the model at any time. Since I haven't trained my model yet, some of these widgets don't show data at the moment. Let's go ahead and train the model now by clicking on the Start Training button. Cranium automatically prepares the data, encodes it in the right format for machine learning, and trains the model with default parameters. All the heavy lifting is done by the platform, allowing you to train your model in just one click. The time taken for training can depend on various factors, including the type of model, the size of the dataset, servers' computing resources, and more. As you can see, the training for this model finished in just a few seconds. It has a pretty high accuracy, and the model metrics are now available. Let's now move on to the Data and Mapping tab. This tab provides a summary of the dataset linked to the AI model. It also allows you to select the features and the target attribute that will be used for training the model. These options give you full control over how the data is mapped to the AI model, ensuring it aligns with your specific requirements. For this model, I am predicting the value of Y, so I have selected Y as my target attribute. The remaining attributes are the inputs or features for the machine learning model, which is why I have selected all of them as features. You can also find additional settings related to the target field on this tab. Here you can select the target field, specify the type of classification, and configure other related settings. You can click on the green check button to save any changes made to the target variable. Keep in mind you'll need to train your model again from the AI Model tab after modifying the target variable settings or mapping. Also, on this tab, you can modify the train test split percentage for model training. This setting controls how much of your data is used for training and how much is reserved for testing. By default, 75% of your data is allocated for training, while 25% is used for testing. There are other widgets on this page that provide a detailed summary of the target variable, helping you better understand its distribution and characteristics. Finally, at the bottom of the page, you'll find the data balancing functions, which allow you to balance your data set. An imbalanced data set can negatively impact model performance. To address this, you can select one of the available data balancing algorithms and click on the Balance Data button. Once again, Cranium handles all the heavy lifting, balancing your data set in just a few seconds. Let's move on to the Predictions tab. This is where you can test the model's inferences by predicting results based on new input data. It's important to note that your model must be trained for the prediction feature to work. I'll click on the Predict button now to generate the prediction. Predictions are very quick, and you can view the results in the output panel on the right. You can now generate explanations and counterfactuals for this prediction. A local prediction provides insights into the factors influencing a specific prediction, helping you understand why the model made a particular decision. Counterfactuals, on the other hand, show you how changing certain input features could have led to a different prediction, offering valuable insights for decision-making and model optimization. In addition to performing single predictions, you can also perform bulk predictions using the Bulk Prediction tab on the top left. This feature allows you to generate predictions for multiple records at once by uploading a file containing the input data. This is particularly useful when you need to process large volumes of data quickly, as Cranium will automatically apply the model to all entries in the file and provide the corresponding predictions in a matter of moments. Let's perform a bulk prediction now. I will upload a file containing multiple records to Cranium and then click on the Predict button. Cranium will process the file and generate predictions for all the entries. Once the prediction is complete, the results will be displayed on the output panel on right. Let's check the results. These are the inferences for multiple leads we just provided to the model. The model is predicting whether each customer is likely to respond positively to the cold calling campaign or not. This information is invaluable for the marketing team, as it allows them to focus on customers who are more likely to make a purchase, ultimately helping to increase sales and optimize their campaign efforts. All right, so it just took us a few minutes to build an AI model, train it with our data set, and generate inferences using Cranium. The platform makes it incredibly easy to go from data to actionable insights in no time.